Good morning, everybody, or good afternoon, depending on where you are. Happy Thursday. Thanks for joining today's webinar. We're going to cover a really exciting and a very new service called Amazon Textract. We're super excited about showing this to you and having you learn a little bit about how to use it. Textract, of course, is an OCR tool. It pulls data and text from sparse or dense documents, even tables, and it's kind of all wrapped up in a convenient API. So presenting on the call today is Chris Burns. If you've been on some of these calls before, you know Chris. He's a senior partner solution architect on the AWS team. He used to be a mechanical engineer who installed and maintained robots, industrial robots, and now he uses his 18 years of industry experience to enable AWS partners across the entire AWS machine learning stack. Also on the call today, we have Chris Screenak. You've heard from Chris as well. He will be helping to answer questions, and I'm going to get to that in just a second. My name is Sue Ewig, and I'm the AWS Global Partner Marketing Manager for AI and Machine Learning. And in the hour or so, a little bit more than an hour that we have today, we want you to feel free to ask any and all questions that you have. This is a call just for partners, no customers. You are not live and open on your audio lines, but we do have a question and answer pane kind of in the bottom right of the navigation pane. So pop those questions in there. Chris Screenak is going to try to go through those and get those answered during the call. If we run out of time and we have just a million questions and we don't get to them, we'll summarize those in an email and send them to everybody after the call. So those are kind of the housekeeping items. And let's pass this over to Chris Burns and we'll get this thing started. Chris?
Thank you very much, Sue, for that great introduction. I couldn't have given myself a better introduction. So I want to thank everybody again today for joining. This is an exciting service. I like this service because it takes something that's very difficult and greatly simplifies it. Invent and simplify is one of the foundational leadership principles at Amazon, and this is sort of action in motion, if you will. So I'm going to a quick overview of the next hour. I'm going to actually start off with what I'm not going to talk about. I'm not going to be able to talk about roadmap today. Textract is not yet GA. I unfortunately don't have a concrete date to give you for when it's going to go GA. If you have some information about that already from any of your business development contacts, that's fantastic, but there's unfortunately nothing I can share about that. And I also, when we get to the Q&A portion of the call today, I'm not going to be able to answer many questions about feature requests or roadmap in terms of features. So hopefully everybody on the call understands, understands our position there, and we can just get to some content. Now this webinar is a little bit different than past webinars because it's not a built-in algorithm. It's a service. It's a service just like Poly or just like Lex or just like Recognition. So the talk today is going to be one part evangelism, I suppose, one part setting the context with the challenges we're facing in OCR today, and then one part service overview. And I'm going to get into a little bit of code, just some Python code. It is not idiomatic Python, so if there's some Python developers on the call today, don't send me any messages about how poor my Python code is. All right, so let me get started into the slide deck with that little bit of housekeeping out of the way. And so, like I said, just a little bit of evangelizing, and not so much evangelizing for the point of evangelizing, but I want to set the context for why OCR is important. Why do we build this service? Why do we, I'm going to take this initiative to make a very, very difficult task simple. And the fact of the matter is that there is a tremendous need for processing documents. If you're on the call today, my guess is that you've had this need before. I've sat in several partner meetings and several customer meetings where they have caches of documents stuck in the analog world, unable to digitize them and extract the data from them because OCR is so difficult. I've seen models trained on OCR that specifically target dense text. That's a text like a book, like a novel or a dense PDF. I've seen OCRs that explicitly target sparse text. Think of an application that somebody might fill out, or the card that we fill out for our gas company when we're.
Hey, Chris. Chris, yeah. Just hold a second. We're having a technical problem here. Nobody can see.
Hey, Chris, can you share your screen? Remember, we turned off screen sharing, and now it's still turned off.
Oh man.
Yeah, no worries.
See. How about now?
Much better.
Thank
Perfect,
you.
Okay,
thank you.
so here's but everybody could hear me rambling on there, right?
Oh yeah,
And
I mean,
oddly,
it's a great
nothing you
introduction,
were
so it's
saying
all
made
good.
any sense without those three icons. Now it's all clear.
Here's the great news. Here's the first slide that everybody missed. Right there. There's the first slide that everybody missed.
Thank you. I
Okay,
feel
so
complete
that's
now.
all right. So let me get back into that zone. I was talking about. I've been on some customer meetings and some partner meetings where there's requests for these. I've seen specific algorithms developed over a long period of time, extensive amounts of hours and resources gone into an algorithm that can only detect one type of text. So I do apologize. I'm a little bit knocked off my rhythm there, but real quickly, let's talk about how documents do get processed today. So there is Textract. Textract has sort of been the stalwart, if you will, of OCR. It's been a tool in the toolbox of developers and such for quite a long time, and it's served a purpose. But the fact of the matter is, it's just simply not robust enough to meet the demands that we're seeing in the field today for OCR. So what we have is a lot of manual processing. We have several different OCR libraries. I probably shouldn't even drop names on different OCR libraries, but there's some out there right now today that are serving some purposes, but not quite fulfilling the needs of what we're seeing in the field. It's also, like I said, it's expensive. It's very error prone. It's incredibly error prone. And one of the things I love about AWS services is that confidence score. Now, we're going to talk more about that at the top of the hour, but why I love that confidence score is it sort of gives you a benchmark, a threshold by which to say, okay, ML agent, I'm going to trust you if the confidence score that you give me is above 85%. What you're saying is if it's above 85%, I've seen the numbers here, I've seen the history, and it's 99% correct if you tell me the confidence is 85%. Under 85%, I might kick that out and add a human in the loop to review that process. Also for OCR today, like I had already touched on, one type of document per OCR algorithm, and they're relatively simple documents. So what we have done with Textract, again, I apologize for trying to get my sync back here. What we've done with Textract is we've made it all right. That should be the last interruption. I should be synced now. So simple documents for current OCR, like I said, very, very error prone. And we have limited mechanisms for determining what words that we're reading. So there's no concept of paragraphs, no concept of lines, no concept of words in most solutions today. Obviously, there's going to be some exceptions out there, and I'm speaking in general terms here. So again, if I say something that might not sound perfectly accurate, please understand this is general terms we're talking in here. So this is an example of a very, very common format that's just simply two columns. Almost every press release or every white paper that we see today, multi-columns. This is very difficult for current OCR algorithms because it has no concept of the geography or no concept of the layout of the page. Another challenge here is animations. Another challenge is these very, very simple tables. This is a very simple table. It's very intuitive for a human to read. We can read it at a glance and immediately understand what the intent of the author is to table this data for us. But for OCR, it's just going to come out in left to right, just left to right, table headers. We also have problems with, charts or tables that might not make sense to computer vision or to machine vision. The output of something like this in traditional OCR, again, we're going to go left to right, up and down. So it's not going to make a lot of sense. It'll be very difficult for us to decipher that in our code. Lots and lots and lots of lines of code for something that should be relatively simple. Yeah, so here, the logical groupings are also missed. The relationships are missed. The author of this has sections for full name. I don't need to explain it to you because I said it's very, very intuitive, but this is all latent information that is we're not able to capture that with OCR today. And so as such, we've seen many partners stymied by a limited accuracy in OCR. We've seen some put some significant development time into solutions that really didn't meet the bar or meet the accuracy goals. And of course, these are very, very brittle with lots of code. So we have Textract now. So Textract is for multiple purposes. Text extraction, as you can imagine in the name, also table extraction. It recognizes tables, and it's going to put that the results of an inference in a format easy for you to consume via code, and also forms. So just a moment here to delineate the difference between a form and a table. A table is tabular. It's going to have columns, it's going to have rows, it's going to have data. Whereas a form, think of the doctor's office visit where you have 47 questions about past conditions. That would be actually in 47 different forms with a key value pair. So it's going to have you ever had asthma, in a little yes no box. Textract's going to recognize that, okay, this is a form, and so I have a key and a value. Now this might be hard to see here because it's hard for me to see. What we have here, this document, this would be classified as dense text. This is a page from Herman Melville novel, dense text. What we're going to do is Textract's going to break this out into blocks. It's going to break it out into blocks of paragraphs, of lines, and words. Each block is going to have a unique ID, and also it's going to have a relationship mapping a block. So if we have a paragraph block, it's going to have IDs mapping child blocks of lines and child blocks of words. So it's very hierarchical, very easy to navigate via code. And I've sort of just explained that this slide in the previous slide. So a couple of API calls. If you've ever used any of the AWS API-based services, we usually bundle several API calls into one service. This API call was detect document text. And what you get back is just about everything. And the block types are going to be paragraph, a page, paragraph, lines, and words. Two different flavors of this detect document text. You have asynchronous and you have synchronous. So if you have thousands of pages that you want to submit, you submit that into the asynchronous API call, and you'll get a notification when that process is complete. Otherwise, if you have a single page or onesie, twosie pages, you can send them up one or two at a time. Also, just as a sidebar here, because Textract is not yet GA, we have a throttle on the API. So if you've gotten if you're using the beta today and you've gotten a message about you've exceeded your rate capacity or some such error, it's a document every 20 seconds. I know that that's not what most people want to hear, especially when we're talking about APIs, but that is temporary. It is until we go GA, which should be relatively soon. So I've got a timer in my sample code for every 20 seconds to send a document. So if you get that error message, now you know why. So tables, what you're going to get is you're going to get blocks back again. Remember, the block is the substrate of Textract results. Everything happens in a block, and it's the type of block that determines what the content is. So again, you're going to get pages, and then pages are going to have tables, and tables are going to have cells. And of course, everything comes with the confidence score. So if you have some blocks that are perhaps typed or text that is very, very clear and easy to read, you're going to get a very high confidence score. If you have some cells where there's some handwriting, you're going to see that the confidence score is going to go down because now we've combined a printed text with a handwritten text. While it still does read both, you're going to see different confidence scores. And one of the nice things, an example I wanted to show but didn't quite get to it, was because in these blocks, you also get geographic information. We'll call it geographic information, a map, if you will. You're going to get a polygon, and you're going to get coordinates in the image as to where this block is. So let's say you have a signature block. Here's where I'm trying to get to this, and you want to verify that that signature is indeed the signature of the individual that's providing a document. You could actually vectorize that image, keep that in DynamoDB, keep it somewhere else. With Textract, you can have the coordinates for the image from the document, pull out that image, vectorize it again, and then go and see, do my image vectors match? You can do that with facial images as well. You can pull those out, send it off to recognition for checking if it's in a face collection, or if you have a list of images, a list of faces with individuals attached to it. So a lot of things you can do with Textract in what I would call not an explicit, an implicit coding. So analyze document is the second API that we have. So we had detect document text, and then we have analyze document. Now this one, I prefer this one, to be honest. I use this one in the demo because it's going to bring everything back. It's going to bring back whatever it finds, because we can put a feature type in here. If you see over here, we have feature types. You can put tables and forms, or just tables or just forms. So it's going to find everything. If you have an unknown document, the example I'm going to show at the end of my talk here, we have a bundle of documents that should meet certain requirements, but we don't know which document is which. We don't know if it does meet the requirement or not. So we're kind of blind, and we have no idea. So we're going to see the example of how we're going to look for just text, for tables, for forms. We're going to look for everything within a document. So here we have an example of a W-2 tax form, and we're going to get back the form fields. So if you have some code that you know that you need a particular line from a W-2, you can hard code that, or you can put some kind of configuration mechanism in place to say, pull out this field from this document, and then integrate that with the business process. And so this is the same API call, analyze documents, with forms as the feature types. Remember, you can do tables, just forms, or both. And when you get tables back, they come back in a page and then key value sets. And then those IDs are mapped, those relationships are mapped, just like every other block within a result. And we'll see those in action here in just a few moments. Okay, I've already talked a little bit about the synchronous and the asynchronous styles of APIs, and I touched on the temporary limitations that we have until we go GA. So if there's any questions about that afterwards, I'll be happy to try to address those as best as I can. Yeah, so just to summarize, the text extraction has been greatly simplified regardless of whether the text is dense or sparse, or if it's forms, or if it's tables. We've built this API so that you can customize the API specifically to the document type if you know the document type. But we also have allowed the API to be extensible in the sense that if you don't know the document type, if you're a little bit blind and you actually need to build a service to identify the type of document, then the APIs serve you well there as well. So just retouching here on the table. Oh, one other thing here that I forgot to mention is that I have seen some OCR systems where they use geography kind of bookmarks, not bookmarks, but what do I want to call them? They use dimensions. They'll measure the dimensions of a cell based on the row height and the column width, and they try to apply that to each subsequent cell. Textract does not need that. So if you have a cell just like this one here, this second row is a different height than the first row. That does not matter. That doesn't matter to Textract. It's very good at detecting these tables regardless of the height of the row, and actually regardless. This one has grid lines. Textract does not need grid lines. All it needs to see is that format of a table. So if we were to take these grid lines away, Textract would give us the same results as if it had the grid lines. And this is just giving an example here of what you would expect results from Textract to be given this image type. I did forget to mention that right today, Textract expects either a JPEG, a PNG, or a PDF. And the limit per image submission today is 5 meg. And then also what I've discovered in my own work is 300 DPI seems to be one of the sweet spot. So you don't have to go real high res on these images. If you were to take a normally scanned document, an 8x10 page, scanned at 300 DPI, it's about 1.5 meg. So well under the threshold for the limit. All right, let's look under the hood here a little bit. So what this slide is really telling us is that, see, W-2s come in many different forms, many different shapes. Not shapes, but we know many different layouts. And with Textract, it can identify that this is a W-2 based on the text, regardless of the format that these particular rows and cells happen to be in. So if you have a process by which, we'll just use the W-2 example, you want to process W-2s, you know that these are going to come back in forms or tables or tables. You know that field name that you need to extract, so you don't have to worry about the layout of the particular W2. And again, talking about the variability. So these are great examples of sparse text, dense text, tables and forms. Photometric, I guess. Photometric is apparently the word we've all been looking for really bad photocopy. But Textract is able to extract tables and text from these as well. I did a couple experiments on this with pretty good results. Now, with something like this, I guess what we're trying to take to the audience today is that it doesn't have to be a pristine copy. I have a couple slides later on in the presentation for setting expectations for an ML project, and I don't want to steal my thunder just yet, but we'll get back to this point in just a couple of minutes. Geometric. I have tested with rotated images. I've tested, right, left, upside down. I've crinkled some paper up. Matter of fact, you're going to see a highly modified version of my driver's license at the end of the call with watermarks and quite a bit of background. I thought for sure that would confuse Textract, but you're going to see that the text comes back. The results come back almost perfect on a driver's license. So as far as geometric shapes go, it doesn't matter if you have some background noise or even some watermarks. So this is a great example here of a document that has forms as well as tables. So we would go back to our analyze document API. We would specify we want forms and tables if we were expecting this type of document, and it's going to be able to pull out information in both form and tabular format for us with a single API call. And here again, looks like I stole my own thunder again. We do not need grid lines for Textract to recognize that this is a table, and that's going to come back. So what I found is, I want to be careful. I want to choose my words carefully. If the text is printed such as this, the accuracy is outstanding. When you get into a combination of handwriting and print, then obviously there are going to be some more, it's a little bit more difficult. So your accuracy may reduce a little bit. But I have some tips and tricks on how to make that trip to the API worth your time in terms of trying to increase accuracy. And again, looks like I do apologize. I presented a couple things out of order here. So here we see variable sized rows and variable sized columns, and Textract does not concern itself with the thick or the height or the width of the cells. Looks like I have a slide in here twice, so I apologize for that. All right, so you know what? I'm gonna break from tradition, and I'm gonna pause right here because I've actually gone over quite a bit of information in a very short amount of time. And before we go further, talk about reference implementations and get to the example and stuff, I want to see if there's any questions anybody in the audience has now.
There's none listed here on the side. I've been waiting, so I can answer questions on the fly too, but oh, here we go.
Does it handle page breaks in the middle of a table? You know what? That's a scenario I have not tried. What I imagine you would get is you're going to send multiple pages, and you're going to get multiple pages back, multiple block objects of type page with multiple tables. And so that's a great question on how would we handle a table that's been split. And the obvious answer there is it's going to take a little bit of code, but I think that all the markers are there for you to put that back together. But I'm not sure who asked that question, but that's a great POC. Matter of fact, it's a very interesting question. I think I'll test that after the webinar today. So if you want to reach back out to me, just drop me a line with your email address. I'll I'll let you know what results I find and what, if there's any tips I have for you for if you encounter that scenario, how to piece that table back together. So is the current throttle at 1 document every 20 seconds? That's correct. Is there a plan to have a library of standard forms on Marketplace? I want to be careful with what I say to this, but I don't think that would be on the roadmap, simply because the number of forms is almost endless if you think about it. I guess if you're talking about W-2s or I-9s or government forms, that's actually not a bad idea. But because of the format that Textract returns the information, I don't know if that's necessary. So maybe if you can put a little more color around that for me about why you would need the forms library, we can get to the service team and see what they have to say about that. So as part of the OCR, does it handle handwritten in the forms? Yes, it does. It does handle handwriting, and we're going to see that here in just a couple of minutes. How will it process different kinds of fonts? So what I've been able to tell is when I modified my license, I wasn't able to replicate the font exactly, and it picked up the different fonts just fine, as well as the different the combination of handwriting as well as typed or printed text. Can you custom train Textract? No, not today. Not today. So our services, just again, we'll touch on that, Poly, recognition, now Textract. The position that AWS has is we try to build a service that's going to cover as many use cases as possible. So if we opened up the the ability to custom train, it sort of becomes a different type of service. And so today we don't allow custom training on Textract. But now that being said, here comes the politician's answer. We have the tools for you on the platform to develop your own algorithms with SageMaker, with the built-ins, and all the resources you might need from P3s to supplemental services to train your own. Will Textract be continuously improved by training with ground truth data? Yes, so all of our services that use inference are constantly being retrained. We're constantly taking the images that we get wrong or the NLP phrases that we get wrong, and we figure out why are these wrong. Let's retrain, let's make it more robust. So we're always fighting, always clawing for increased accuracy. 1/100th of a percent here, 1/100th of a percent there. All right, so that looks like that's all. Oh, no, a couple more questions. Sorry.
Chris, just one you passed by here. Is it possible to enhance Textract to identify things such as citations?
It may be possible. It may be possible because I was surprised that quotes came back up. I'm sorry, apostrophes. Apostrophes came back in the text. So if apostrophes came back, then that tells me that there may be an opportunity for quotes to come back. I don't think it would recognize things like italicized text just yet, because it would just see that as a different font, and it's going to come back in a standard standard data. But it may be possible to find quotations. So let me also, I'm going to take that as also as a deliverable to figure out what the service team has planned for that if it's not possible today. Does AWS use data for any internal purposes? We would like to use it for more sensitive data. So again, I'll be careful with my answer here. We don't. It's a fundamental policy at AWS. The security comes first. Privacy is wrapped up within security. The resources that you use on AWS are managed by us from a hardware perspective, but the data is yours. We don't have access to the data. Now, in the case of a service like this, it may be possible that if we get a bad result, if we get a missed inference, that they may try to retrain on that, but I don't think they would do that without reaching out to you first. So again, I want to make sure that I'm very, very clear that I don't have the details of that. So please don't take that as gospel, but that's another conversation that we can have for the person that asked that question. You let me know, obviously don't share the data with me, but what type of data, and then we can reach out to the service team and we can see what they have to say about that. So a sample use case would be to do Textract and then pipeline output to SageMaker. Of course, if you have reams and reams and reams of analog paper data, and you need to develop some models based on the contents of that data, Textract is your first step. Textract is going to get you from analog to digital. It's going to get it from that printed text into data, into font data print text. I tripped over my own tongue there. And then you're gonna be able to use that data for training purposes on SageMaker, absolutely. Today, Textract will support what languages? Today, it supports any language you want as long as it's English. But I would have to venture a guess that based on past services, other languages should not be far behind. But again, this is not a service that's GA yet, so I don't want to put any more pressure on the service team to not only deliver the service in English, but then additional languages. How long does it take to process a single page from a book? It's usually milliseconds. Again, it's going to depend. It's going to depend on the size of your image. Did you max it out at 5 meg, or is it something more on the lower end, like 100 kilobytes? But this is an API. So if you've ever used any of our APIs like Recognition or Poly or Lex, you know that our APIs are very, very responsive. They're very crisp. They're very, very quick to get the results back. So everything is measured in milliseconds. I can't give you an exact answer because we have such a wide range of image size as well as image content. Dense text may take a different amount of time than forms or tabular data. Can we get access to the pre-release? Yes, there is I believe it's on the site, AmazonAWS.com/Textract, and there should be a beta, a request to join the beta link. So is all the data stored in memory, or is it copied somewhere for this conversion? We don't store results. I think this is where the question is going. You get the results from memory, output to a memory stream via API, and then those results are yours to keep in whatever format that you want to keep. Well, we don't keep those results. Okay, so it looks like all the questions are taken care of, and so let's get back into some reference implementations here. So the obvious one here is simply you have some documents, you drop them in S3, you have a Lambda function that's going to detect those documents via an S3 event. It's going to call Textract, and it's going to give you the output. That's what you get with this reference implementation is you get a completely serverless. So when we say serverless, that's synonymous with scalability, with speed. You have all the features such as CloudWatch and CloudTrail to monitor and audit that, and you get that at a price point that is unmatchable, to be honest, when it comes to building the service on your own. And in this particular example, they also appended an Elasticsearch service at the back end. So usually the scenario I've seen is the scope of the OCR project, we'll call it, is known. It's known. So you have an example like I'll give later. I have I'll give the example a little bit, but if you're just scanning documents and you don't know the content of them, if you don't know what you're looking for, then services such as Elasticsearch are the perfect addendum or the perfect supplemental tool that you would need to search the data that you've just created. So for the gentleman that asked the question about could I use this to export data to SageMaker? Yes, you can. And so when you're processing your data sets after you've converted it from analog print text to digital text, you could use services like Elasticsearch or Pandas if you want to put that in CSV format, whatever service you want, it's available for you to process the data afterwards. So form capture. This particular one was if you're in the field, if you're mobile, you're at the edge, and you could take an image with your phone. Because Textract works on image, you can simply send that image in a synchronous manner to Textract. You get the results back, and if they're at the edge, you can take action, or you persist that data somewhere for a cloud-based transaction. And this was the example we've been talking about for SageMaker. Extract for NLP. You send probably something that, in the asynchronous, you want to send thousands of pages probably to Textract and get that large corpus of digital data and prepare that for NLP processing. Yeah, and the message there is you're going to quickly turn that stacks of paper data into actionable insights. Which brings me to my use case. The text is also black here. So I live in the Austin, Texas area, and there's been tremendous growth in this area in terms of new homes built. And I discovered this very arcane process by which I had to submit a permit application to the sheriff of Texas County for my home alarm system. Makes perfect sense. There's thousands of homes being built every year. Also, the people that already have alarm systems need to renew their permit every year. Travis County Sheriff is not set up to handle this type of processing. And also this covers if my alarm goes off because the dog moved in the middle of the night and it's a false positive, then I get like one freebie a year and then I get charged for that. So this is a means by which it helps the sheriffs manage this process. But I had to submit this application, this permit. I had to submit my license and a second form of ID. Now, again, I've heavily modified these documents for the presentation. So there's no personal information on here in case you were feeling uncomfortable about that. Now, what I wanted to do was I got very curious when I called the sheriff's department about this process. And I said, how do you process these documents? And they said, well, you either mail them in paper format or you can upload them in a zip file. So 3 scanned images in the zip file, and then some individual, a human, sits there and they process these documents all day. And so what I created for us today was this document verification system. So I've taken these 3 images, I've put them in a zip file, we drop them off on S3, and then what we're going to do is we're going to do 2 things primarily. First, we're going to verify that the required documents are indeed in that zip file, and we're going to do that blind. So I don't know if the first document is the permit, if it's a license, if it's the second form of ID, or if it's something that doesn't even belong in there. I have no idea what it is. So we're going to verify that all 3 documents are there. And then after we verify the documents are there, we're going to verify that the required information is in these documents in order to process that application for my security alarm permit. And we're going to do this all with about 150 lines of code in the single Textract API. Now, here's where I wanted to talk about some expectations with AI. I recently gave a presentation on these 5 pillars of AI, and pillar number 2 is the scope of the project. Sometimes we set expectations incorrectly for services, for our own projects, and we think because it's machine learning, then that means we should be striving for 100%, and that's correct. But I want to just very, very quickly, I want to be mindful of everybody's time. When we're talking about the performance of machine learning, I break it down into 3 levels: below human, at human, and above human. So obviously below human, that means that you're not going to get the same accuracy that you would expect to get from a human. At human means you're going to be on par, and superhuman means you're going to get accuracy far and above that of a human. Now, what I mean by this, let's take the example of the sheriff's office. This is from the limited information that they're willing to share with me. They have, I believe, 1 person processing these documents, and they can process about 50 documents per hour. And I don't know if that's documents or if that's in total applications, so that means 150 documents, but I don't think we need to worry about that. I do know that humans are about 95% accurate, even on the simplest task, because if you take a simple task and you do it repeatedly, your accuracy is going to begin to suffer. It's just one of the facts about being human. So I estimate that a single human can do about 400 documents a day with around 20 errors. Now, with machine learning, I'm going to go low here. I'm going to say we hit 70% accuracy, which your first instinct may be to say that's terrible. Well, no, it's not terrible, because think about this. It's 70% accuracy, but I can do 5,000 documents an hour. So what I do then is I take the known goods, the ones where my confidence score is at a level that I'm happy with, and I just say, okay, these are good, process them. I don't expect any errors. If it's below that confidence level, I'm going to kick it out. I'm going to keep my human in the loop, and they only focus on the documents that can't be processed by my machine learning process. So what you get is you get an augmented human process by which you can process tremendous amounts more data than by means of just human alone. So when we talk about our expectations for a project, if you feel like your accuracy is not hitting 100%, that's okay. You can take steps to mitigate that by keeping that human in the loop and a couple of other things. Oops, this is the point. I'm gonna break out of the PowerPoint. I go very simple code. It is all Python. Again, I already gave my disclaimer about it's not idiomatic. So if you're not a Python developer, don't fret. I'm going to go over this in layman's terms. I'm going to go over it at a very high level. And really the point of this is to show you almost how simple it is. You saw the flow chart for the process that I've built here. You saw the 3 different documents. One is the permit, one is my license, and one is a second form of ID. And so right off the bat, just a handful of import statements. And a couple of these actually aren't even used anymore. Now, what I've done here is I've put my business logic, we'll call it business logic, into these little dict objects here. So for my document check, I have a permit, I have a driver's license, and I have a birth certificate. And then I have what I call some keys here. What this means is if I find this data in my image and I find this data in my image, then it's pretty safe assumption, high 90s probability, that it is the permit application. It would be very rare for me to find these 2 terms in a document that was not my permit application, especially in a service that's expecting permit applications. And I did the same thing here with the driver's license. I'm expecting the term driver license, and I'm expecting also the term DOB, date of birth. And then again, same with the birth certificate. Now, what this does, if we go back to the flow chart, I'm not going to actually go back, but remember the first step was to verify that the documents that were required were indeed in my bundle because they're blind. I have no idea what's coming up in the zip file. And then the second one is my data points. What data do I need from my permit to begin processing this transaction? What data do I need from my license? And what data do I need from the second form of ID? So let me pause. I'm gonna give a quick disclaimer. This is a I don't want to call it a fictitious scenario because, to be honest with you, I think the Texas Travis County should build this and simplify the process, but it's not production ready, of course. So if I've cut some corners here, I shouldn't even use that phrase. If I've simplified something here or omitted something there, like a lot of error checking, a lot of logging, don't presume that I expect you to take code such as this and just throw it out there in production. Okay, so we can ignore this. This was just, I dropped an image. I'm sorry, I dropped a file in S3, and then I captured the event JSON. This is the event that's fired that kicks off a Lambda function. So I just captured that, so I didn't actually have to drop files in S3 while I was writing my code. We can ignore that. And we're going to go right here to the Lambda handler. Now remember, the Lambda handler in the event, we're going to get this text back that I just closed up. This is the text in the event. And what we see here is the name of the S3 bucket, which I call Textract landing, and the name of the key. And I called it burns5622.zip. That's all the information we need to pull that from S3 into our Lambda function. I'll be mindful of the time here. I'm going to go very, very quickly so that we can have the last few minutes for more Q&A. And so here's where I extract the key from the event. Remember, this is a dict object, D-I-C-T, so I can just map it based on the format of the object. The very first record in the S3 object, key, and I'm going to pull out that field. I'm going to download the file. Now, remember, in Lambda, you can only download to the temp directory. So if you trying to download, you get a permission denied error. Don't think it's your role. Don't think you've done something wrong. You need to download to the temp directory. That's /temp. So I drop it there, and then I just simply unzip the file. I keep going back to this point, but I want to make sure that I stress the point is I don't know what's in the zip file. I'm completely blind here, and I'm leveraging Textract to not only pull the information out of the documents, but to tell me what documents they are. That's the point I'm trying to make here with this bit of code. And so here we're gonna just iterate over the documents that we've just unzipped. So I'm gonna create this. I'm gonna open the file. I'm gonna set it equal, the contents of the file equal to this data variable. Now here's where I just take this file bytes. I created some lists because I didn't get to this actual step in the process, but like I said earlier, maybe I want to revisit an image and take a piece of it and send it off to a different service. Maybe I want to take that signature and do a vector on that and go verify, is this the same signature that I have from this individual and other documents? Maybe I want to go out and hit recognition. Maybe I want to send this to Polly and have it read back to me. So by keeping a copy of the contents of the file in memory, I can do that very, very quickly without the need to go back to the file or go back to Textract. Remember, with APIs, I love to stack APIs, call multiple APIs. I've never hesitated to go back to an API to get different information. But obviously, you want to be smart with your API calls because that's where you're going to incur cost. That's where you're going to incur latency in your application development. So anytime you can keep something in memory, it's always wise to do that. And then so I have my result here. This result variable is going to be populated by my call to Textract. Textract is my context for the Bot03 resource, and I'm calling analyze document. And then here I'm passing the bytes. Now, when you call analyze document, you can either point to an image on S3, of course, or you can pass in the bytes themselves. If you notice here, I opened this document with RB. That's binary. You need to pass bytes to the Textract API. You cannot pass a string to that. And then also here, I've specified that I want you to find, I'm speaking to Textract here, Textract, please find me all tables, please find me all forms. So I want everything back from this document. Now, I'm going to store those for however many documents I have. Hopefully it's at least 3 and not more than 3. Here's where I'm going to make a list of, based on these, remember I call this my business logic. These are the documents I'm expecting. These are the points of data I'm expecting in the documents. And I'm going too slowly. I do apologize. And so here I'm going to verify that the required documents are present. How you do this, I've simply wrapped it in a simple loop, and I've created this little function called verify docs. And very simply, it's very simple. So I'm going to take each item in my content, and the content in this is my business logic. I'm going to say, okay, these are the documents I'm looking for, and these are the keys to prove that that document exists. And it's so simple. It's just if this key is in the item, because at this point in time, I can just query. I can use Python's internal string processing to just say, is this key in this text? If yes, then I know that the first key is there, and then I check the second key. So you could probably find more robust ways of doing this. Obviously, you're going to want to put some safeguards in place, but it's again, the point here was to just stress how simple it was to say, okay, both of these keys are in this document, so it's probably my permit. So at this point in time, I have downloaded the object from S3. I've sent it to Textract. I've got my results back. I've verified that my documents do exist. Now I'm going to verify that the data points are in the document. So I'm going to come back up here. And you know what? I'm going to put one more. Let me check my questions. Yeah, we had a couple more questions, and people aren't leaving the call yet. So let me pause here again real quick. I'm going to pause here, and I'm going to see if there's any questions so far in what I've built here. Hopefully, I've painted a picture as to the use case. I've painted a picture to how simple the code is to extract these values. Now, obviously, there is no back-end business process here. I'm not the sheriff's department that has some kind of system that says, okay, approve the permit, add this permit to our database of permits, add Mr. Burns's address. But I do want to at least show you a couple more things here. When you're navigating the results at first glance are a little bit intimidating. That's not what I wanted. Okay, so these are the results. I'm gonna make sense of this in just one moment. And I also want to show you the picture that we sent. Okay, so here's an image of the permit. So you see it's a combination of text and forms. It's a combination of printed text as well as handwritten text. And there are some forms here. And I do not actually live on Sesame Street, but I thought it was pretty safe to use that. And then what I'm going to do here, see, I've taken the time to format this in a little bit easier to understand manner so that you can see those blocks and so you can see those block types. As soon as I can find it. I apologize. I was not going to present on this machine today, but then I realized that you cannot present GoToWebinar on a Linux machine. Okay, so I've begun to format this in a pretty print. I could have just used a bit of code to do this for me, but I'm in a hurry. So what we have here is the primary object of the result from a Textract call is the blocks. Everything comes back in blocks: pages, lines, words, forms, tables, cells. Everything is a block with a specific block type. And then within that block type, you're going to get the geometry, which is what I talked about earlier, the bounding box, and you're going to get the polygon. Each block is assigned a unique ID. And what this ID is used for, of course, is hierarchical reference. This particular block has children. Now I've omitted many. Every single block within this page is a child of the page block. But for readability purposes, I've deleted hundreds and hundreds of GUIDs here under the child IDs. And then we see that the very next block is a line. Here's the text of that line: Travis County Alarm Permit Application. We see this right here: Travis County Alarm Permit Application. Now, I only left one block of each type in this because this is for readability purposes. It's not. And so for Word, now the child of this line block type will be all the words in that line. And we see that the first word that I kept was Travis, and it makes perfect sense. And then the subsequent words would be Travis County Alarm Permit. And now the table, I did not format the table. I do apologize. I was pressed for time, but the table, and the reason I didn't format the table is because this is not a table. It is a form. So the results for a table were basically empty. Then we get down here to the form, which is a key value set. And we see these relationships here. Now, once I've shown you this, I want to jump back into the code to show you how I navigate this relationship. Trying to be mindful of the time. Okay, so a lot of for loops here. I know it's a little bit confusing to follow. I'm going to share this code with everybody. I'm going to drop it in a GitHub repo so you have this as a reference if you want to play with Textract. But for the last time, I'm going to stress that I didn't know what documents I had. I didn't know what to expect. I didn't want to assume that these were particular documents. So I wrote the code as such that it actually verifies the documents for me. And then I have my requirements. And for each requirement, I'm going to look through the blocks. I'm going to break it down into a key map, a value map, and a block map with these subsequent functions right here. So hopefully that makes sense. And I'm going to be able to extract based on these key maps in these block maps. So let me go back to the questions. Okay. In asynchronous mode, where do results get stored? You get the results in asynchronous mode. You simply just don't get them back in a matter of milliseconds. You get those back. You get them back in the exact same format that I just showed you. It's going to be in the JSON format made up of blocks, but you're going to get it back when documents are done processing rather than immediately. So if you send 100 pages to the service in asynchronous mode, you're going to get a JSON result back that has 100 page elements, and then each page element will have multiple block elements. So here's a question about fraud. So there are some things you could do here as a developer, as an intelligent person to detect fraud. Obviously, I didn't do that in this example because technically speaking, all three of these documents are fraudulent. I've changed things in these documents, and there's no way to know. But let's take the driver's license, for instance. Let's say you want to say, okay, I've got this image. It has the word driver license on it, and it has DOB on it. Let's now measure it. Let's take the geographical marks and say, is it a 2x3 card, or, whatever license is, 2x3, whatever. Does it have a picture on it? Is the picture of the individual that I have in my face collection, or maybe you don't have a face collection, but is there a face on it? Even recognition will tell you if there's a face on it. So you can begin to build a process by which you reduce the propensity for there to be fraud. Also with the signature, you could take the coordinates of that signature out of the image you send to Textract and compare that to an image vector. So there's things that you can do, things you can build, and those are what I call the implicit capabilities of Textract, because it's giving you not just the text back, it's giving you a map of the document back. So you can recreate, if you use the console, if you use Textract's console sample, we do that. We recreate the document based on the results, and we highlight the fields in the document. So there's plenty of tools there for you to begin a journey down the path of detecting fraudulent documents. Right. So not batch mode on the asynchronous call. And now we are a minute over. I want to be mindful of your time. I know how hard it is to sit through one of these to begin with. And I want to thank you very much for your attention today. Like I said, I'm going to get this, all this information is going to be distributed to the attendees. There's a recording of this, so if I was talking too fast or if I didn't make any sense, you could go back and listen to it and try to make sense of what I said. And I think with that, I will hand it back over to Sue. Once again, thank you very much. I really appreciate everybody's time and attention today.
Hey, Chris, thanks. That was great. Very cool example using good old Travis County. Hey, everybody, before you sign off completely from the call, we've got 5 questions, a super quick survey. We would love it if you would just take that survey. I think it's actually as soon as you log off the call, it'll pop up. So if you could take 90 seconds and do that, that would be great. And we will be back in 2 weeks. Chris Greenack actually is going to be covering PyTorch in the enterprise. Yeah, in a couple weeks. So hopefully you can join us for that. You will get an email. Say again, Chris?
Fresh from F8. I was just at the Facebook conference.
So in about 6 hours or so, you will get an email from GoToWebinar with a link to the recording from this call, as well as a registration link for the next couple of calls that we have scheduled. So take some time and sign up for the next few calls. And happy to be with you today. Hopefully we'll see and hear from you guys in about 2 weeks. Take care.